Hello guys, phenomenal day, right? How true. Today we are going to be proving the 0 factorial. How it is that this 0 factorial is equal to 1. In the last video, this is where we stopped and I told you I'll be proving it for you on this video, right? How true. Now, for those of us who have not seen the last video, Introduction to Binomial Theorem, please do well to check it out, okay? Very true. Now, the 0 factorial is giving us 1. And how do we handle this whole piece? How is it possible? Now, in the last video, I told you that the general formula for the factorial is given as n factorial equal to n multiplied by n minus 1 multiplied by n minus 2 down till you get to 2 times 1. 2 times 1. Let me write that down properly. 2 times 1. Now, for the general formula, this is what we have. Now, if we were to find n minus 1 factorial, n minus 1 factorial, n minus 1 factorial, this would give us n minus 1 multiplied by n minus 2 down till you get to 2 times 1. Let me quickly explain that. Finding f minus 1 factorial here in itself, what we just did was to follow the general formula. So the general formula says if you have to find the factorial of a particular number, in this case n minus 1 factorial, let me write this properly, n minus 1 factorial, what you do, you present that value first. So we presented n in the general formula first before we begin to subtract increasing value from it. So now, since we are going to present n as per the general formula, so here we also present n minus 1 first. So n minus 1 comes first. Then we begin to subtract increasing values from n minus 1, right? Here, for the general formula, we subtracted increasing values from n. So we subtract increasing values from that particular value, right? So here we have n minus 1 minus 1, right? And you keep on doing that till you get to 2 times 1. And this whole piece gives us that n minus 1 factorial gives us n minus 1 multiplied by n minus 2 down till you get to 2 times 1. This would be how we derived n minus 1 factorial, right? Moving on, let me take that off, then we'll continue. Now, if we are to find n factorial divided by n minus 1 factorial, n minus 1 factorial, how do we do that and what do we get? So what we're going to do now, we're going to put all the values of n factorial at our numerator. So let's insert that. So n factorial gave us n, right, multiplied by n minus 1 multiplied by n minus 2, and that continues till you get to 2 times 1. So at the denominator now, we are going to still have the values for n minus 1 factorial. The values for n minus 1 factorial, which was n minus 1 multiplied by n minus 2 down till you get to 2 times 1. So that will be n minus 1 multiplied by n minus 2 down till you get to 2 times 1, right? Following the laws of division, you see that there are some common terms here that can cancel out, right? So those values can cancel out. So for instance, n minus 1 is at the numerator and n minus 1 is at the denominator. So this goes, right? This goes, right? Yes, it cancels out. N minus 2 is at the numerator and n minus 2 is at the denominator. So this goes. And it happens just that same way and in that same pattern till you get to 2 times 1. So 2 cancels out, at the numerator and 2 cancels out as the denominator. 1 cancel 1 here at the numerator and the denominator, right? How true. Now we are left with n factorial divided by n minus 1 factorial, n minus 1 factorial, leaving us with just n. We have just n left from our divisions here, so we are having just n. Now I want to make n minus 1 the subject of my formula, right? N minus 1 the subject of my formula. So what we do is we cross and multiply. So if we should do like this, and this like this, we have an imaginary one here, right? Very true. So we are left with n here, n minus 1 factorial multiplies n, right? So n minus 1 factorial multiplies n, and n factorial in itself just multiplies 1, so that leaves us with n factorial. Now I'm attempting to make n minus 1 factorial the subject of my formula, so I divide both sides by n. Dividing both sides by n, divide by n, and here n cancels n at the numerator and the denominator, right? So moving on, we are left with n minus 1 factorial, giving us n factorial all over n factorial all over n. This is how it goes. Now I want to eliminate this minus 1 from this side, right? From this side of the equation. Let's eliminate it. And one of the ways we can do it is to add positive 1, is to add 1 to both sides, right? So let's add 1 to n in the equation. So adding 1 to n we would have that n minus 1 plus 1. So wherever we see n, we add 1. So let me write that down. Add 1 to n. So wherever we see n, we add 1. So here also at this side of the equation, we are going to have n plus 1 factorial here, factorial, and here also we are going to have n plus 1, right? So on this side of the equation, we have that. So on this side of the equation, n minus 1 plus 1, we are left with just n. So minus 1 plus 1 cancel out, and that gives us 0. So we are left with just n. And on this other side of the equation, we are left with n plus 1 factorial all over n plus 1, right? So let's work this up into our proof of the 0 factorial. Our proofs of the 0 factorial. Now let's take real values, starting with, let's say, 4 factorial. Now 4 factorial, we should put a factorial symbol here and here, right? So 4 factorial, let's take n to be 4. Take n equal to 4. Now 4 factorial gives us, now we are going to substitute n for 4 in our formula. So we have 4 plus 1 factorial, 4 plus 1 factorial all over 4 plus 1, right? 4 plus 1 factorial all over 4 plus 1. So in the aftermath, we have that this gives us 4 factorial. 4 factorial would give us 4 plus 1 here gives us 5 factorial. 5 factorial divided by 5. 4 plus 1 gives us 5 factorial divided by 5, and 4 plus 1 at denominator still gives us 5, right? So this, if we should open this up, this would leave us with 5 times 4 times 3 times 2 times 1 divided by 5, right? Divided by 5. And mind you, remember from the last video I told you that according to our general formula, 4 factorial should give us, we start multiplying from 4 down till we get to 1, right? 4 times 3 times 2 times 1. So let's see how this whole thing plays out. Does it give us the exact same value as our 4 factorial? Let's see. So let's see what can cancel out. 5 at the denominator cancels 5 at the numerator, right? So we're left with 4 times 3 times 2 times 1. So it means that 4 factorial from our general formula, which gives us 4 times 3 times 2 times 1, is still equal to 4 factorial as per our calculation, 5 factorial divided by 5. So for us to calculate the factorial of a value, right? A value, for us to get the factorial of a particular value, all we need to do, another way for solving it apart from this our general method, 4 times 3 times 2 times 1 as per 4 factorial here, you can simply take the factorial of the next value after it, or we can just add 1 to that value and divide by that value, right? So such as we are doing here, 5 factorial divided by 5, right? So let's try out 3 factorial. 3 factorial divided by 3 factorial equal to, now our formula says 3 plus 1 factorial, 3 plus 1 factorial divided by 3, right? This gives us 3 plus 1 rather. This gives us 4 factorial divided by 4, right? So this gives us 4 factorial divided by 4, and this would be equal to 4 times 3 times 2 times 1 divided by 4. So 4 cancels out and we are left with 3 times 2 times 1 would be 6. Now moving downward, we would notice that the same thing happens for 2 factorial. 2 factorial now would be equals to 2, right, plus 1 factorial, close this bracket, divided by 2 plus 1, 2 plus 1. So this would be equal to 3 factorial divided by 3, right, divided by 3. So that would give us 3 times 2 times 1 divided by 3, and this goes, right, and we are left with 2 factorial giving us 2, just like we had in our previous video, right? 2 factorial gives us 2. Then 1 factorial now gives us 1 plus 1 factorial divided by 1 plus 1, right? So that gives us 2 factorial divided by 2, right? And this gives us 2 factorial is 2 times 1 divided by 2. 2 cancels, and we are left with what? 1. So 1 factorial is 1. Can you feel the drum rolls now? For 0 factorial, the reason why we are here today, 0 factorial. Let's prove that and let's see what it gives us. Now 0 factorial now gives us, now according to our formula, we're going to add 1 to 0. 0 plus 1 factorial, 0 plus 1 factorial divided by 0 plus 1, right? How true. So 0 plus 1 factorial gives us 1 factorial divided by 1, right? So this gives us 1 over 1, and 1 divided by 1, guys, gives us absolutely 1. So that is how we can prove that the 0 factorial gives us 1 mathematically. Thank you so much for watching. Why don't you click on the next video? We're going to be studying combinations in the next video. Remember, kids, you are what you think of yourself, right? So think positive thoughts. Tell yourself, I'm smart, I'm intelligent, and I'm the best I can be. All I have to do is make myself better each and every day.